it is going to be gone. And so you can't do it anymore. Any questions about that? You good? Okay, let's tackle tonight's agenda. I like this lesson today. I think it's fun. That's just my opinion. Okay, we're going to do the lecture first, and then we're going to talk about the example problems. I'm going to do the college algebra ones after I get the lecture part done. This is the lecture portion, and you can get those, pull up those notes if you want to. Change my pens here. Some of these are things we've already talked about. For instance, this first one is that type that we're going to do is find the value of a function. Now, we've already done that, but it's in the support section this time again. So we're going to talk about it again, just in case you missed it. Remember, functions are in this h of x form. I could just as easily say that's y equals x plus 9. When I put a value in there for x, it kind of looks like this. I'm going to put in x of negative 10, and it wants me to find the value of the function if x is negative 10. And so all I'm going to do is put that negative 10 in that x spot, and you will learn that if you put parentheses around your substituted in values, it will save you some grief when you have negative numbers put together. So I must always put a parentheses around my values that substitute in. Now I have a negative 10 plus 9, and that is difference of that one. You have to subtract because of the different signs, so I get negative 1. Now in this section, they will call this an output. So it will say, what is the output for this? If you don't know that that's the Y answer, you might not recognize what to do. This 10 then is called the input. This negative 10 is the input. The negative 1 is the output in this section. It also makes an ordered pair. You put in negative 10 and you got out a negative 1 when you put it into the problem. So that's one of the things that's a little different about the value. They call them a little bit a different name in this section. Then they're going to ask us to expand our multiplication of binomials. So they throw some fractions in there, which means you're going to have to use your fraction tool. But they do quantity. It's called quantity squared. You have a quantity in here, and you're going to square the quantity. Now, most people will give me an answer of 25x squared plus 1/4, and that's just not right. And so many people do it that I decided I wasn't going to ever teach the rule for this anymore. I was just going to tell you that this means to write this down twice. That 2 up there means to write it down twice. And then I quit having people miss this problem. So that's what I'm going to tell you guys. If you see something like this, a binomial or a trinomial even, that has a little 2 out here, all that means is that you're going to write this as a product of each other. So this is 5x plus 1/2 times 5x plus 1/2 is what that actually means. Now you can see that you have a full problem. First, outer, inner, last. And so 5x times 5x for the first would be 25x squared. Then outer is 5x times 1/2. Now you may have a little bit of trouble with that. You may have to come over this side and see what that looks like. 5x times 1/2, you can put the 5x over 1. 5x times 1 is 5x, and 1 times 2 is 2. A positive times a positive is a positive. So you really just have 5 over 2x or 5x over 2. Either way over that you want to write it. You can write the x outside the fraction, or you can put it up there with the 5. Just don't put it down there with the 2. That's not where it can go. Right? Then the inside ones, the inner ones, is the same thing. I've already done it, so I know it's 5 over 2x. And then last is 1/2 times 1/2. 1 times 1 is 1, 2 times 2 is 4. So I have a 1/4. Now, because these two in the middle are both x's, I can combine those. So I have 25x squared, and 5 halves plus 5 halves is 10 halves. You add the numerators and keep the common denominator. Now, some people will try to put that in your answer, but it won't take that. Somebody tell me what's wrong with it.
It would be 5x.
This 10 halves is not reduced. So your author will not accept an answer that's not reduced. So 5 over 10 is 2. So you have 10 over 2 is 5. So you have 5x. Now, this is one that when you're putting the answer in and you get to this section down here, you're going to have to come down to the bottom and select that little box that looks like it looks like a fraction bar with 2 spots for you to put in the numbers. So just keep in mind that's how you're going to be able to do that. Now, there are some tricks to by-step that, and some of you will figure that out really quickly, but the easiest thing to do is go down and pick your tool that looks like that, and you can put your fraction in to your system. Any questions on that problem? I promise you, you will have one of those on the test. So look out for that little quantity squared. Looks like that. It has a little 2 outside. It means you write it down twice and multiply.
So it'll always be 5 over 2x because it's 5 over 1x, correct? Is that how you got?
I did 5x times 1 in the top. That would be 5.
Because it's
And
okay.
1 times 2 in the bottom.
Okay.
You
I
can
just wanted to
always put them
clarify
over 1. If it's by itself, you can always put it over 1.
Okay. I just wanted to clarify on that to make sure I had it right.
You got it?
Yeah, thank you.
Okay. All right, let's go further. This is one that some of you may not remember doing from way ago. Some teachers don't like to teach this, and so they kind of skip it. This is the third kind of problem you're going to have. 1/3 plus 3/4. And in the bottom, 5/6 minus 1/3. This is called a complex fraction. Notice it is not an equation. It's one of those that you're going to get a common denominator for, but it's not it doesn't have an equal sign. So the rules for this are a little bit different than those rules for those other two that we talked about at the top of tonight. For the complex fraction, you're going to check out all of the fractions that you have in the problem. So if I check those all out, I'll have a 3, a 4, a 6, and another 3. Those are all of the denominators that I have. So when I'm doing a complex fraction, what I want to do is to not get it so complex. So I think of a number that 3, 4, 6, and 3 will go into. So I need a common denominator
12.
for all of those. What is it?
12.
12.
12.
12, because 3 will go into 12 4 times. And again, you're thinking larger, not smaller. 3 will go into 12, 4 will go into 12, 6 will go into 12, and 3 will go into 12. So we're good with 12. Now then, I take each part of this and I multiply it by that common denominator like I did on those other problems I had. But this one looks a little different when I get through with it. Let's see what happens. So, now again, you can put your 12 over 1 if you want to. I just set them up there. I know it's in the top, but if it bothers you for them to be sitting up there in the sky, then put it over 1. Now I'm going to cancel my
Hello?
3. I'm sorry?
Okay, I guess something was wrong with my audio, but I'll wait till you get finished. And I was going to ask a question about the one we just did. I kept trying to say something, but I didn't think you could hear me, even though I was unmuted. So I just got out of Zoom and pulled it back up, and now you can hear me.
Well, I understand because I had that problem last week. So wait till I finish this one, and then I'll go back to that one, okay? Is that a deal? Okay. All right. 3 will go into 12 4 times. 4 will go into 12 3 times. 6 will go into 12 2 times. And 3 will go into 12 4 times. So notice that all of these denominators that I have circled up here are all canceled out now. That's a good thing. That means I won't have as many. So now I do 4 times 1 is 4 for that one, plus 3 times 3 is 9. And then I have on the bottom 5 times 2, which is 10, minus in between 1 times 4 is 4. So I have 4 plus 9 on the top and 10 minus 4 on the bottom, which looks much less complicated than this original one did. Now all I have to do is add them together on the top and subtract them on the bottom. And if I could reduce it, I would reduce it, but I can't reduce this one. So my answer is 13/6. Now, before we go back to that other one, is there a question about this one? We'll do another one of these in just a sec, but you have one like this on your homework. Okay, let's go back to the old one and let's see what the question was. What was the question you had on this one?
Okay, I had a question. You see how it said 5x plus 1/1/2?
Right here?
Yes. Would the answer be different if you put, in place of the 1/2, put 0.5? Would the answer be different?
No, the answer won't be different, but if they give you fractions in your original problem, they're probably going to want fractions in your answer. So
Right.
I'm not sure if you put 0.25 right here, if they'll take it. They should take it, but somebody probably needs to put one of those in there and answer that question for me and see if they will take it. I think sometimes they do and sometimes they don't, is what the truth is. But my general rule is if they give me fractions here, I don't change them to decimals. I just leave them as fractions. But they should take it if you put 0.5 instead of 1/2, it should be okay.
Okay.
Try it and see. See if the author will let you do that. If not, you can always use your calculator and change it back to a fraction. We learned a couple of ways to do that first week of class. You can go to math and change your decimal back to a fraction and just put your fraction in. Let's look at another one of these complex fractions and see another form that sometimes they take. You can have x to the 5th over y to the 8th, and you have one like this on your homework. Y to the 5th over x to the 6th. Now, that's pretty complex. You can even hardly tell where the divided between the two would be. Now, some of you are probably thinking you could just do the old divided by rule and multiply by the reciprocal and do this problem like that. And absolutely you can. You can do that. This one's simple enough to do that. You could use this as your divided by and put this one down, multiply reciprocal with this one, and it'll work. But we're going to follow our same rule we've been following because it works with those more intricate fractions that you'll run into. you can see that you've got denominators because this is a heavier line here. You've got denominators of y to the 8th and x to the 6th. So your common denominator that you want to pick for both of those to go into would be y to the 8th, x to the 6th. It's just the combination of the two. So I'm going to do it from this point. I'm going to multiply here by y to the 8th, x to the 6th, y to the 8th, x to the 6th. Okay? Now you can see what happens. These y to the 8ths cancel. And in the top you have x to the 5th times x to the 6th. You're multiplying, so you add the exponents and you get x to the 11th. In the bottom, cancel out your x to the 6th and add your exponents and you'll get y to the 13th. And that's your answer. It doesn't take long to do those. You just have to know what to do. All right, questions? Let's try this number 5. These are square roots. Now we're going to do a lot of work with square roots in this class, and while I'm at it, I'm just going to tell you what a square root graph looks like. It looks like half of a parabola on its side. That's kind of an intro of what square roots look like. Now we're not ready to do that yet. I just thought I would add it just because it's fun. And I thought I would just let you know that's kind of what we're going to do. Your problems are going to look like the square root of 3 minus the square root of 5 times the square root of 3 plus the square root of 5. This is a binomial times a binomial. So I'm going to FOIL it. Now the rule for square roots is that you can multiply inside numbers. You can multiply outside numbers, but you can't multiply inside to outside. So I'm looking at my numbers. These are both inside numbers because they're inside the square root. I can multiply those. Square root of 3 times the square root of 3 is the square root of 9. That's my first. My outer, this is an inside, this is an inside. I can multiply those. Square root of 3 times the square root of 5 is the square root of 15, and my plus goes between it. Inner, have a negative sign. A negative times that positive is a negative. Square root of 5 times the square root of 3 is the square root of 15. Those are both inside numbers, and you can multiply them. Then last, I have a negative times a positive. Square root of 5, square root of 5. I can multiply those, and I get a negative square root of 25. So those were all inside numbers. So I could do that at first, outer, inner, last thing on those without any trouble. Now then, that will not be the answer that's in your system because, number one, I have a positive square root of 15 and a negative square root of 15. Those things, when I combine them, will cancel by addition there. One's plus and one's minus, and so those will cancel out. Now, I have perfect square roots. Those are called perfect squares underneath those square roots. So I can bring those out from underneath the radical symbol. And there's a radical symbol on your calculator. So while we're looking at it, in case you don't know automatically what the square root is, there is a square root symbol on your calculator. Anybody find it? Where is the square root symbol?
Second x squared.
Mm-hmm. Do you see that it's right above that little square?
Second x.
So I have to do second because it's in blue, and then do the x squared, and look, it puts a square root symbol in my calculator. So if I put a 9 underneath there and I just didn't know the square root of 9, I could figure it out, and it tells me it's 3. Now, if you try to do something like the square root of 15, like we had in there, even though those canceled out, I get this long decimal number that will not change to a fraction. That's because there's no perfect squares in that 15 as it sits right now. 5 times 3 is the only way you can get
Can
15.
you give me my whiteout over there?
Yes, Mom.
And so that's the situation there. Now, the square root of 9 we found out was, was 3, and the square root of 25 is 5. So now this minus comes down here between them. 3 minus 5 is 2, and it's going to be negative 2 because 5 is larger. Any question on that? Let's combine two things. Let's combine 2 plus the square root of 5 and quantity square it. Okay, I hope you're remembering how to do that from the couple of problems I did before. If it's quantity squared, that means it's a quantity in here and it's a squared term out here. You use this and write it down twice because that's how many times it should be multiplied by itself. 2 plus the square root of 5, 2 plus the square root of 5. Okay, now we're ready to FOIL it. So my first would be 4. My outer ones. Now see, this is where you have a 2 and a square root of 5. You're not going to get square root of 10 because 2's on the outside and 5's on the inside. So what you have to do when you have that situation and you're multiplying is just write them down next to each other. That's what it means when you do write them down next to each other. It means 2 times the square root of 5. So that's the way you want to write it. Notice 2 is an outside number. It doesn't have any square roots around it or in it or over it. And 5 is an inside number. It's underneath the square root. Now look at this one. Those are the same way. You have another 2 square roots of 5. And we usually put our outside number on the outside of the square root. Then on this one, when I multiply my last terms, I get the square root of 25. I see that these do not cancel like they did in the last problem. And it's like if it's the same as if it was 2x plus 2x. Those square roots of 5s are the same kind of square root. So what I would do for this part right here is combine 2 square roots of 5 and 2 square roots of 5 would be 4 square roots of 5. Looks like that. Then I'd see that this should be 5 because the square root of 25 is 5 times 5. That take a 5 out, and you have the square root of 25 is 5. If you didn't know that, you can put it on your calculator. So I have a whole number here and a whole number here. I can add those together, and I get 9 plus 4 square roots of 5. That's my answer. Now, again, across the bottom, you're going to have this little square root tool. When you get the, you'll put the 9 in plus 4, come down and pick your tool, put your 5 in there. You'll have to watch out for that little tool to put your square root in. Okay, we're going to do one kind of factoring because it's the kind you're going to need for this assignment. There's all kinds of factorings. If you don't know how to factor, I'll put up a sheet when we get into some factoring that will have all the rules for all the kinds of factoring. But the most common kind of factoring that you use all the time in this course is the difference of 2 perfect squares. You know, 25 is a perfect square, 9 is a perfect square. Anything that you can multiply by itself, like 4 times 4 is 16, so 16 is a perfect square. 9 times 9 is 81, so 81 is a perfect square. So you might want to just think about those kinds of perfect squares that you would have. In one of the other courses, we make a list of them that we can use as we are doing factoring so we can recognize our perfect squares. But if you had a squared minus 4, and you want to factor that because you're going to cancel part of it into another part of your problem, then what you would do, that separates into 2 binomials. The a squared separates for the first position numbers into a and a, so that when I multiply back by 4, I would get a squared. The last one separates into the last position numbers, and it's 4. So I don't want to have a middle number. So the way I could do that is 4 and 1 or 2 and 2. But if I put 2 and 2, when I subtract them, I won't have a middle number. Now, one of them will be a plus and one of them will be a minus. And now we can check it by full to make sure we're right. A squared for the first terms. Outer would be negative 2a. Inner would be positive 2a. And so those would go away. Then last would be negative 4. So any kind of difference of two perfect squares will factor into two binomials, the square root of the first one, the square root of the last one, and one plus and one minus between them. Now we'll do a bunch of those, so if you've forgotten that rule, you'll do it enough times in this class that you'll practice it enough, you'll recognize those difference of squares. The one that, like you're going to have in this class for one of the assignments tonight, has a little more to it. Instead of just a squared minus 4, it's something like 4x squared minus 9y squared. So you see you have got a group of squares here. 4 is a square, x squared is a perfect square, 9 is a perfect square, and y squared is a perfect square. But it still factors the same way. This first position number is going to factor in this first position and be 2x and 2x. And do you see if I multiply back, I get 4x squared. This last position is going to be 3y and 3y. And if you multiply those back, you get 9y squared. And you have to just remember that there's one plus and one minus between them. And what that does is cancel out your middle term. So there's no middle term in between there. Okay, that's just a little review on the difference of squares. Any questions on that? You're going to need that in one of the assignments tonight. All right, let's talk about composition. Composition is what this is called for Billy, who can't remember what they're called, but that's called composition. Maybe it wasn't Billy. Whoever it was that said you didn't know what they were called. Was that Eric, maybe? You didn't know what.
Yeah, that was me. I don't know what they're called, but I know how to do them.
Sorry, Billy. You probably do know what they're called. But he said, I don't know what they're called, but I can do them. So that's kind of the way I want you to be able to do. Yeah, as long as you can do them, we're in good shape. You're going to have a couple of functions like we've been working with. I told you this whole course is full of functions. That's what you usually work with here. And in this one, I've got a line. Let's go back to kind of the beginning where we remember that this is a line. And this is a parabola because it has that square term. This is a line because x is to the first power. This parabola is moved down 3 where the vertex is. It's down 3 because of that 3 on the outside. So don't forget those. You're going to need those throughout the course. So to do the composition, what that means is that you put one function into the other. You're going to grab one of them and put it in the other one. So we're going to start with numbers because numbers are easier. Now, this is the symbol for composition. It looks like fog, F-O-G, but that's really a little tiny circle. Some of my students say they're in a fog when they do this, but you're not really. You'll come out. So it says F composed with G is what that says. F composed with G, and they want us to put in -6. So the rule for this is that you have to look at the last one. You want to do the last one first. So I'm going to pick the G because it's mentioned last. So this is my G function up here. It says x squared minus 3. So I'm going to put this -6 in the G function first. So I'm going to find g of negative 6. That's going to be negative 6 in a parentheses squared, and that square does go on the outside. The only thing you're substituting in is that 6 where that x is. That 2 stays out there. So you have negative 6 squared minus 3. Negative 6 squared is 36 minus 3, and that's 33. Okay. Instead of coming back like we did when we found f of negative 6 and g of negative 6, and we were adding them and subtracting them and multiplying and dividing, this time is different because you're putting one into the other. This time what you do is pick up the 33, and if you use the g first, now you're going to use the f, and you're going to find f of 33. So you're putting this answer into the other function. So I'm picking up my negative 4x minus 1. I'm going to put 33 in there minus 1. This is my old f function. Comes down here. Okay. Now, negative 4 times 33, I think, is negative 132 minus 1. So I get an answer of negative 133. So my answer for f composed with g of negative 6 is negative 133. I'm going to write that. Negative 133 is your answer. So you put the negative 6 in the g first. Get that answer. When you get that answer, put it in the f. If it had said g composed with f, you would have put the f first and then the g. So whatever's mentioned last there is what you want to do first. Now this is the hard part of this. This is where I have people that have trouble. So I'm going to try to do my best to make sure it's as easy as it can be for you. You have a f of x is x minus 2 and a g of x is x plus 2. They first want us to do f composed with g of x. Okay, that means we're not putting a number in there. We're putting the whole equation in there, the whole rule. That's the rule part of the function. Remember, g's mentioned last, so I'm going to go over to g and pick it up first.
So
And
you would put g into f, is that what this question is telling us to do?
yes, it is.
Okay.
So you're going to pick this. That's exactly right. I'm glad you see that. Pick up this g, the whole rule, the x plus 2 over here, the whole thing. And you're going to pick it up, and you're going to bring it over here where this x is in f. And where that x is in f, now it's not going to say x anymore. You know what it's going to say?
X plus 2.
X plus 2. So all I did was pick this whole thing up, put it here where the x is, won't say x anymore. Now in my spot where my finger is, it's going to say x plus 2. But see, I still have this minus 2 on this outside here, so I've got to put that down too. Now I simplify it, and I get x plus 2 minus 2 is just plain old x.
Okay, you said, did you cancel that out or?
Yes, a 2 and a
Okay.
negative 2 will cancel each other out.
No, what I mean is, so you plugged x plus 2 into that equation over here.
Right.
Okay.
See where my finger is? I just picked that up and put that where my finger is. So it says x plus 2 where my finger is, but that minus 2 that's there, see that minus 2? That's still a part of my problem. It came down there. I just put the g of x in that x spot.
Okay.
Now, on these problems, they're going to want the domain of the answer, of the composition. You'll have to be careful with this, and I'm going to do a real complicated one in a minute for part of the college algebra examples. So you college algebra people need to stay with me through at least one more problem because it's a tricky one. And the domain on this, remember, this is just y equals x is all that is. That is a line. What's the domain of a line? We already did all that. What's the domain of a line?
All real numbers.
All real numbers. But they're going to switch on you now, and they're going to do it in interval notation form. So all real numbers in interval notation form is negative infinity to positive infinity. And down on your little toolbar down there that's across the bottom, there will be an infinity symbol for you to use. So you can pick it off of there.
Real quick on that note, now that I did remember that, make sure you put the parentheses in your answers so you don't get it wrong.
If you don't put parentheses around infinities, you will get it wrong. So be sure you do that. You'll have to put parentheses and a negative and then pick off the infinity symbol, put it there, comma, pick off this infinity symbol here and close it. I don't think they give you the ordered pair, do they, Luke? Don't you have to put in the infinities both times?
Yes, ma'am. You got to put in the parentheses, the infinities, the commas, all that stuff.
Yeah, I think you do. But remember, that's all real numbers. It's what that is. It's just in a different form. It's in that interval form. Okay, any questions on that part? Let me go the other way just so that I can do it one more time for you. If we're going to go the other way with G composed with F, we're still using the same functions. We're still using x minus 2, and G of x is x plus 2. We're still using the same two functions. But because F is mentioned last, I'm going to pick it up first. See how it's mentioned last in that parentheses right there? I'm going to pick it up first. So I'm picking up this x minus 2 instead of the one I had over here. And I'm going to put it over here in the G function for x. So it's going to say x minus 2 plus 2. Because I put it in for that x right there. So that where that little box is, now it says x minus 2, because I picked this up and put it in there, plus 2. And of course I get x on that one as well. And my domain, because that's a line, is negative infinity to positive infinity. Now, for those of you that made all those hundreds on the assignment, I want you to open your ears. And everybody else, you don't have to listen, but just those people that made those hundreds, I want you to listen. Because this makes y equals x, and this one is y equals x. Those things are called inverses of each other.
Scoot up the paper a little bit because I can't see the bottom. Thank you.
You're welcome. Now, the rest of you, we will do inverses. So I know this is a lot of new stuff for you, so you don't have to think about that. But those people that need more to think about, there's you something else to think about. Because they both equal to x, they're called inverses of each other. And we're going to do those in a couple more weeks. We'll be doing inverses. All right. I want those of you that are in college algebra, I hope you haven't left me yet, because we need to do one of these problems that's tough on this section. It's the very last one. It's number 6 on your homework problems. And
Is this the college algebra homework or the support homework?
this is the college algebra homework. This is the number 6. Number 6 is the toughest one. So let's start it. It's f of x equals 9 over 1 minus 8x. There's my f function. G of x equals 1 over x. Those are your original functions. Before you do anything with those, because they're fractions, they are called rational functions. And our domain is no longer going to be all real numbers because there are some undefined places on these graphs. So before you even do any composition with these problems, take your denominator and set it equal to, not equal to 0, so that you can find out where these are undefined. So if I solve this one, I would get negative 8x cannot equal to negative 1. Divide both sides by negative 8. And I see that for this first one, the f function, x cannot be equal to 1/8. On the second one, I see that x cannot be equal to 0. It's on the bottom. I don't have to solve anything. I just need to know that x cannot be equal to 0. All right, let's start the composition, and we'll start with f composed with g. And we're just doing it of x, so that means we're picking up the whole thing and putting it in there. So g is mentioned last, so I'm going to pick up the g first, and I'm going to bring it over here, and I'm going to put it in for x in the f. So when I write that, it's going to say 9 over 1 minus 8. That's all part of f. But then I'm going to put 1 over x in that x spot because I'm moving it from here to that x spot there. So it's taking away that x, putting in 1 over x. Now this is a complex fraction, so I need to get rid of those denominators. The only denominator I really have is that x. So what I want to do is multiply by the common denominator x in all the places, and I'm going to rewrite it so that you can see what I did. Going to take the x, I'm going to multiply it by the 9, I'm going to multiply it by the 1, and I'm going to multiply it by this 8 times 1 over x, so that I have it in all the places that were in my original problem, the 9, the 1, and then this group right here. Now when I get through with that, I will have 9x in the top, 1x, these x's are going to cancel each other, and I'll have negative 8 times 1, which is negative 8. Okay, now then, do you see that this has something in the very bottom down here? You see it? That means there's something that I can't put in here for x because it's going to make this denominator 0. So I'm about to do the domain for this. So I need to set my 1x minus 8 not equal to 0. Add 8 to both sides, and I get x cannot equal to 8. So I know that x cannot be 8 in this final problem, so I've got to skip the 8. The problem that you've got to always remember is there is a hidden, it's what I call a hidden function that you can't see any longer. The hidden function is what you started with. It's kind of, see, this looks like the f function. So hidden inside, because we put one function in another, hidden inside that is this g function right here. It's hidden there. So when I get down here at the bottom, I've kind of lost my x not equal to 0 up here because my function got hidden inside there. It's inside that f function. So I have to also consider that x cannot be equal to 0 from my hidden function up here. Now then, that's a little bit hard. My domain is going to be all real numbers except x cannot be 0 and x cannot be 8. I've got to consider both of these because this is hidden inside and this was from the one that I got from the answer right here. Now, they don't want to put it in set notation with all real numbers. They want us to put it in interval notation. So I've got to consider which one of these is my lowest number here. 0 is lower than 8. So if I'm going to my number line left to right, I'll start over here at negative infinity and I'll go until I come to the 0. It comes left to right before the 8 will. Put my 0 in there, use a parenthesis to skip it. Union, we talked a bit about this the other day, but now we're actually doing it. There's the 0 again, and what this does is skip the 0. And I'm going to go from 0 to 8 is okay. But then I've got to skip the 8. And then I can go on my merry way to positive infinity. So when you have two values, you'll have two of these that you'll have to put in between there. You'll have the lower one, it's the lower bound. You'll have to put it here. And then in the middle, it'll go from the 0 to the 8. And then you'll skip the 8 by using this union in between and using your parentheses. So you have two answers to this problem. The first one is the composition. This is the composition of f composed with g of x. And this one is the domain. And they won't let you put your domain in until you get your function in. And you have to go both ways. You have to go g composed with f and f composed with g. We'll do that g composed with f in a minute.
I have a question.
Yes.
Why don't we include the x cannot equal 1/8?
That's a great question because you used this f one last. So you have this problem and it put this inside here and changed your problem a little bit. So it's not the same kind of, it's not the same function at all as the one that you had over here. But it's not hidden inside there. That's the one you stuck in there. You know, you use that part. So your hidden one is the only one that's here. This is the hidden one. It's the second one. That's the one you have to consider the domain on. But that's a great question. You don't use the one that's the main portion of what you are working on. It's the hidden one is the one you have to worry about. I don't think I answered your question, but maybe.
No, I think you did. So the hidden one is just going to be the first one that you use. Like it's always gonna be-
Mm-hmm. And
Okay.
it's the second one that's in your composition.
Right. Yeah, that answered my question. Thank you.
All right, let's go the other way and see if we can do it. Because this is really the hardest problem on today's work. Let's use those same ones. F of x equals 9 over 1 minus 8x. And g of x equals 1 over x. And remember that x couldn't be equal to 0 on this one. And the x couldn't be equal to 1/8 on this one. This time we're going to go g composed with f of x. And this time we're going to pick up the f because it's mentioned last. And we're going to put it over here in the bottom where that x is. So that x won't be there any longer. It's going to be 9 over 1 minus 8x down there. The 1's going to stay on top. But the bottom now is going to say 9 over 1 minus 8x. See how that goes in the bottom? Now, this one doesn't have a denominator. The only denominator I really have, because this is my big long one, is this one. So my common denominator is going to be 1 minus 8x. It's the thing I'm going to use to multiply the top and bottom by. So I have 1 times 1 minus 8x over 9 over 1 minus 8x times 1 minus 8x. It's kind of the way that looks. That's kind of funny looking. These two will cancel. You can distribute 1 here. And it looks like you're going to have 1 minus 8x on the top and just a plain old 9 on the bottom. See that? That is one of your answers. And again, you'll have to pick that tool that looks like this because that's a fraction. And in the top, you'll put 1 minus 8x, and in the bottom, you'll put 9. Okay, now, this doesn't have any that have to be thought about, excused, not used, that will make it undefined, because there's no variable in the bottom. There's a 9 in the bottom. That's okay. Just can't be a variable down there. So for the G composed with F of X, that is just that answer right there. But for the domain that I'm looking at, I would have all real numbers if I just had this. But I always have to consider the hidden one. Now, in this case, which one is the hidden one?
Is it 1 over 8?
It's the one that says X cannot be 1 over 8. It's the F one. It's the one that I put inside the other one. It's the one that's mentioned last. That's
So
the
for the hidden function, it's always the one that's last, correct?
That's the hidden function. So I've got to consider that domain that I had for that hidden function, that X cannot be equal to 1/8. So I've got to remember that because it's hidden inside there. I've got to say that X is not equal to 1/8. To do that, I would go from negative infinity up to 1/8, union 1/8 to positive infinity. Notice I didn't have 2 areas to worry about this time. I just had the one, the hidden one.
With all of that, just a tip, it lets you work one out and then answer the domain, then work the next one, then answer the domain. So don't confuse yourselves when you're working those out.
That's true. Does it ask for both compositions and then ask for the domains of each one of them?
I think it does both. It switches it up depending on the problem.
Okay. It seems like I remember that the one I worked, it asked for each of the compositions and then it asked for the domain of each one of them. I remember I got it wrong. And I said, why is that wrong? And I put it in for the wrong one. I answered the wrong one. I answered the one for F composed with G, and I thought I was doing the domain for G composed with F. So be careful on that. Make sure you know which is which. All right. We're going to stay on the college algebra section. That's the harder of the 2 sections tonight. And I'm going to do the other 5 problems in the college algebra. Do I have any questions before I do these example problems from college algebra 9.1? There's only 6 altogether, so there's only 5 of these to do. We did the 6th one. Any questions? All right, let's start. Number 1 is f of x equals negative 4x minus 1, and g of x, this is similar to the one we did in the lecture. They want us to find f composed with g, and they're going to give us a number for this one, -6. We're going to do g first. We're going to put -6 in for g. So I'm going to say g of -6 equals -6 squared minus 3. When it's a number, it's easier, I think. So you have 36 minus 3, which is 33. I think this is the same problem we did earlier. Now, you've done the g. Take this answer that you got from g and put it in the f function. So you're doing f of 33. You're putting into 4 times 33 minus 1. And that's -132 minus 1, which is -133. You don't have domains to do on these. You don't have the crazy compositions. It's not a rational. Neither of these are rational, so you don't have to worry about anything on those. Number 2, f of x equals 4x plus 5, and g of x equals x squared minus 2x minus 4. So we have a parabola and a line. Both of those have domains of all real numbers. Again, we're finding g of f of a number. So I'm doing the f first. It's mentioned last. So I'm doing f of 4 first because it wants me to put 4 in the f function first. So I have 4 times 4 plus 5, putting that x, that 4 into for that x, which is 16 plus 5, which is 21. Now I put 21 into g. So 21 would be g of 21 equals 21 squared. That ought to be interesting. Minus 2 times 21 minus 4. That's going to be 441 minus 42 minus 4, which I think is 395. So any questions about those first two?
I'm almost finished with that. I'm just writing down the last line.
Okay.
Okay.
Really quick, I just wanted to make sure whenever you're writing the answer, or like putting the answer in, do we just write it as the plain number, just 395?
Yes, there will be a little box right there. And in the box, you will write 395.
Okay, I just wanted to make sure we didn't have to put in any type of weird notation or anything.
Yeah, I know. I don't think there's how many weird ones. If they do, send me a note. Like that x not equal to, that if you didn't put the x not equal to, it was wrong. Yeah, watch out for those. If you're sure your answer's right, then look to see what form you've got it in. Maybe it's a form problem. You just have to play the right game for the computer to take it. Or text me, and maybe I've done it before and we'll remember what the little secret is. Okay, number 3 is 6x plus 5 is the f function, and x cubed, remember this cubed looks like that. This is a line. So those are all real numbers for domains on those, but that's not what we're doing on these. We're finding on this one f composed with g of -4. Okay, g's last. So I'm going to find g of -4, I'll put f, g of -4 equals -4 to the 3rd power. -4 times -4 is positive 16. Positive 16 times -4 is -64. Someone asked me, when you're substituting in numbers like this, do you put the parentheses around the number with the exponent outside? And the answer to that is yes. Okay, now then we're going to put negative 64 in the f function. We have 6 times negative 64 plus 5 when I put it into the f function. And that is negative 384. I'm cheating by looking on my sheet I did already. So I get negative 379. When you get to number 4, they're going to start asking for the domain on this one. So on number 4, we have f of x equals x plus 4 and g of x equals x minus 4. And we did one like this earlier. They're going to do f composed with g of x first. That means that you're taking the g and you're going to pick it up. Since it's of the x, there's no number for us to use. And you bring it over here. And where that x is, you're going to put in that g function. Don't put that x in there at all. Put that x minus 4 in there. And you still have that plus 4 as part of your problem. Now, x plus 4 minus 4 is just plain x.
Why do I got a 62?
Where did you get 62?
Oh, no. That wasn't for that. And I thought I was muted. I'm sorry.
It's okay. Where did you get 62? Was it for the one before? Should get 64, I think. 4 times 4 times 4.
No, I didn't get 62. I was talking about something else.
Oh, okay. All right. Now then, they want the domain. The domain for this is in negative infinity to positive infinity because none of this has any rational things on it. There's no undefined places. Okay, now let's go the other way. Remember that f of x is x plus 4 and g of x is x minus 4. And this time we're doing g composed with f of x. F is mentioned last. So you pick up the f and you bring it over here and you put it where the x is in the g. So now it's going to say x plus 4 minus 4. And that's just x. So the domain is negative infinity to positive infinity. You're going to have a box to put this x in, a box to put this in, a box to put this x in, and a box to put this in for your answers.
Will there be an infinity symbol?
Yes,
on the
it's
blackboard?
across the bottom. It's across the bottom. It's listed. I don't know where it's listed, but
Okay.
I don't think there's a negative infinity and positive infinity. I just think there's an infinity symbol.
So you would just
We'll
do
have
a
to put
minus.
the negative in
before.
front of the negative side.
Okay.
Yeah, it'll print it in there for you.
Okay.
Okay, there's one more of these. And it's a composition. So this time they give us f of x equals x plus 4 and g of x equals 2x squared minus 7x minus 4. This is a parabola. This is a line, no rational ones here, so we don't have to worry about undefined spots. So the first thing they want us to do is f composed with g of x. So g is mentioned last here. I'm going to pick up this g, the whole thing, and I'm going to bring it over here and I'm going to put it in that x spot. So where that x is, I'm going to take that out and I'm going to put that 2x squared minus 7x minus 4 in there. And don't forget, I have that plus 4 that's still sitting on the end there. It comes down here on this end. It didn't go away. It's still there. Now, when I combine like terms, I get 2x squared minus 7x. The plus 4 and the minus 4 cancel each other out. So this is all I have for an answer right there. And my domain is from negative infinity to positive infinity. Now let's go the other way. The other way is a little bit harder. Remember, we had f of x is x plus 4, and g of x equals 2x squared minus 7x minus 4. This one takes a little effort. You're going to do g composed with f of x, which means you're picking up the f first and putting it in the g. So this right here is what I pick up. And this time I have 2 x's to put it in. There's an x right there in the x squared plus spot, and there's an x right there. So there are 2 places in this one for me to put in my x plus 4. So I'm going to be real careful when I write this. I'm going to bring my 2 over, parentheses, and where this x is, I'm taking it out, and I'm going to put in x plus 4. And that little 2 is still there, so it's quantity squared. Then I'm putting the minus and the 7, and where this x is, I'm going to take it out, and I'm going to put in x plus 4. Be sure you put it in parentheses because you're going to need to distribute that. And then that minus 4 comes down. Now, I have to be careful with this because this is one of those quantity squared things that I did at the beginning of class. That really means x plus 4 times x plus 4. I'm going to leave that in that form while I do some work over here. I'm going to distribute that, and I get 7x minus 28. Don't forget that minus sign there. A negative times a positive is a negative, minus 4. Now I'm going to work on this a little bit. I'm going to leave my 2 alone, and I'm going to see what this is. First would be x squared. Outer would be 4x. Inner is 4x. And last is 16. I still have this 2 on the outside of this group. I did first, outer, inner, last. Minus 7x minus 28 minus 4. Now I've got to distribute my 2. I could combine like terms first and distribute the 2, but I'm a little bit lazy, and I decided I don't want to do that extra step. I have to combine anyway in a minute, so I'm just going to distribute my 2. So I have 2x squared plus 8x plus 8x plus 32 minus 7x minus 28 minus 4. Now I have a bunch of stuff, so I can combine some things. There's a 2x squared. I'm going to put it first because of the squared term. I've got a bunch of x's, 8x and 8x and 7x that's negative. So how many x's does it look like I might have? 16 minus 7 is how much? 9. And I have 32 that's positive, minus 28 would be 4. 4 minus 4 would be 0. So I don't have any kind of number. This is my answer right here. Oh, there's something else I can do with it. Oh, that's a squared. Sorry, I left out my squared term. I would have been able to combine it. That's a parabola, so my domain is negative infinity to positive infinity. Okay, that is the college algebra section. It's all about composition. Questions?
Did I miss the part where 28 and 4 went away?
32 minus 28. This right here is 4. And 4 minus 4 is 0.
I got it. I see it now.
Any other questions? I know this is a little bit hard. Composition's a little bit hard. Students sometimes don't like composition, but it's kind of like a puzzle to me. And I like the ones that have the hidden part to see if I can figure out what the domain is that's hidden. I like those, but you might not like them. So if you get stuck on them, don't skip them. At least try them. And the answers are multiple choice, so eventually you'll get the right answer. So know that. Now, on the test in the quiz, it's not going to give you multiple choices. You'll mean it'll have multiple answers, but it won't tell you, no, it's wrong, try again. You'll have to just try it one time on the test in the quiz. So kind of get used to doing those. All right, for the next 10 minutes, we're going to do the support examples. And we're going to start with number 1. And you're going to find out that these are so much easier than those other things that we were doing. All right, it starts out pretty easy with an h function. They want you to find h of 0, and you're going to say, oh my gosh, I can do this. I just put 0 in for x and find the answer. And they give you a bunch of those. H of negative 17 is negative 17 plus 9, and it's just whether or not you can add and subtract on most of these. Then there's an h of negative 10, which is negative 10 plus 9, which is negative 1. Then there's an h of 3, which is 3 plus 9, which is 12. But this last one you might have trouble with, y plus 14. Well, don't let it be too big a problem for you. All you're doing is putting y plus 14 in the x spot. So y plus 14 plus 9 is y plus 23. So don't let it be too big a problem. Okay, any questions on that? That seems easy compared to what we've been doing. Let's skip number 2 and go to number 3. I think you can do number 2 if you can do number 1. Number 3 is 5v plus 1/4 quantity squared. Now, somebody asked about decimals. You could change that 1/4 to 0.25, but you need to change it back to a fraction using your calculator when you get through. Before you put your answer in, since it starts with a fraction. Remember this little 2 up here that means a quantity squared. So this is a binomial that I'm going to square, which means I write it down that many times. 5v plus 1/4 times 5v plus 1/4. Now later on we're going to have things that say cubes and squares. Cubes and to the 4th power and to the 5th power. So that just means the same thing. You're just writing it down how many ever times that exponent says. Now we're into the full life. We have to full this out. 5v times 5v is 25v squared. The outer one, 5v times 1/4. Do I need to come over here and write that down? See what that looks like. 5v times 1/4. I could put the 5v over 1 and times 1/4 and multiply the numerators and denominators, and it's plus, so I would have 5v over 4, or I could write it as 5/4 v, as I did in the example that we did. Since those are the same numbers, I'm going to have the same thing. I'm going to write this one the other way so that you can see I could write it either way with the v in the top or the v next to it. And then 1/4 times 1/4 is not 1/8, it's 1/16. 4 times 4 is 16th. The most common mistake I get on a problem like this is getting the 1/8 there. Somehow in your brain you want to add instead of multiply. So now I have 25v to the second. 5 fourths plus 5 fourths is 10 fourths, not 10 eighths. So be careful on that. Now, if you put this in, they're going to count it wrong because this 10 fourths can be reduced to 5 halves v. Okay, any questions on that problem? Okay, let's skip number 5 because it's just like that one, and go to number 6, which is one of these that is a complex fraction. It's a complex fraction because you have fractions within a fraction. That's what it's called, complex. So pick out your fractions, your denominator. There's a 6 and a 7. So I need a common denominator for 6 and 7. Anybody know what it is?
Mm,
42.
42. 42. And I've got to multiply every part of this by 42. So I'm going to rewrite it so you can see me do that. 3 times 42 plus 5 6 times 42. And again, you can put your 42 over 1. If that bothers you, just stick it up there in the air. 2 times 42 minus 4 sevenths times 42. See how I multiplied every part of this by 42? Okay. Now, 3 times 42 is 126. And over here, these 6 will go into 42 7 times. 7 times 5 is 35. In the bottom, I have 2 times 42, which is 84, minus 7 going to 42 6 times. 4 times 6 is 24. Now that looks much easier than what I started with. So when I add 126 and 35, I get 161. And when I subtract 84 and 20, I get 60. And that one will not reduce. So that is my answer. Okay. I want to be sure I get to number 9 before everyone leaves me, because number 9 has that factoring part. 16a squared minus b squared over ab. It has this big long fraction bar, and it says 4a plus b over a. So this is definitely a complex fraction. I have a denominator of AB and a denominator of A. So I need a common denominator for AB and A. Something that AB will go into and A will go into. Anyone have an idea?
AB.
AB. All right. Now, because this is on the top of a fraction bar like this, and this is on the top, and I can think ahead to see that this is going to factor and this is going to end up canceling, then what I'm doing is multiplying the top by AB. I'm going to rewrite it so you can see what I did. Multiply this top by AB. And this bottom by AB. Now this AB is going to cancel, and this A would cancel into that A, then you have a B left. So I have 16a squared minus b squared over b, I'm going to move it to the front, times 4a plus b. Now, I know, because I did this problem earlier, that what I have is a difference of two perfect squares. 16 is a perfect square. A squared is a perfect square. It's difference, so it's minus. And b squared is a perfect square. So this top thing is going to factor into two binomials. The 16 will go in these places in the first. It's a first position number. So I'll have 4 and 4 make 16. 4 times 4 is 16. I also have a squared in that first position. So that's going to make an a and an a. And if I multiplied it back, I would get 16a squared. The b squared's in the second position, or last position in this case, b and b. And remember that when you factor difference of squares, there's one plus and one minus. Now put your denominator on there, and you can see that there's a group that's going to cancel. We'll do a whole bunch more of these in this class, so this is just the first of many. Those would cancel because they look exactly alike. So my answer is 4a minus b over b. Any questions about that problem? All right, our time is up for our class, but those of you that want to stay, I will be glad to answer any individual question you have or do some more from the support section. Otherwise, I will see all of you on Thursday, and if you just want to chat, it's okay. I like to chat. You can tell I don't get to see a whole lot of people during the day, so when I see you at night, it just does something to me. I like seeing you guys.
I have a question.
What is your question?
Okay. I know this might be stupid,
Oh, there's no
but I'm a little, honestly, I am a little bit, I'm missing some screws. Anyway, so I just realized, because I remember back when the class first started, and I didn't know if I was in support or college algebra. I didn't realize that, and like a idiot, I thought